Alright, this is your study guide for quiz 6. And your first 4 problems come from this same diagram. You got a hexagon and a triangle. The dashed line segments form 30-degree angles. So question number 1, find the image of P. Here's P. After a rotation of 240 about M. 240 about M. This might be the hardest problem on here. So if you're going to rotate P around M, M doesn't move. So look, if you put a line from P to M and extend it, wouldn't this, do you see this rotation right here? That's P going around M. Wouldn't that be 180 degrees? Okay, and now you just have to use your imagination a little bit and maybe be a better circle drawer than I am. But if you continue this circle around point M, that's 360 about M, right? Well, you only hit 2 more points, don't you? You only hit K and you only hit or O. Well, if this is 180, what is this? Does K look like 240 or does O look like 240? Yeah, because this, well, the center, if you take this 180 line and you break it in half, this would be 270, wouldn't it? Well, you don't need to get to 270. There's your, if that's your 270 line, there's 30 from 270, so it's point K. 240 about M. Got it? You're going around point M. You're orbiting point M in this problem. And I got to erase everything, so, but it'll be on the video because I got to mark up this drawing again. I got to do that for each problem to try to explain this business to you. In problem number 2, find the image of OQ. O to Q is this right here, this segment. After a rotation of 240 about point O. Point O is your center of rotation. And now you're going to rotate 240 this way with this segment. Well, if you get around to here, isn't that 180 degrees? There's a 180 rotation of that segment. But you need 240. And each dashed line is 30 degrees. So this is another 30 and this is another 30. So 180 plus that 60, here's your 240. So it puts you on OH. Here it is. It's this rotation right here. You're rotating a segment, but the end point O of the segment doesn't move, and Q keeps rotating around this hexagon. Number 3, find the angle of rotation about O that maps JK to FG. We're going from JK to FG, and we're going around point O. So this is a simply counting, just count how many sections it rotates. It goes 1, 2, 3, 4 sections. And each dashed line represented 30 degrees. And 4 times 30 degrees is 120 degrees. So 120 degree rotation. It's the same thing as if you were rotating this triangle right here. If you were rotating that triangle around point O, then point O or vertex O would stay the same and the triangle would just keep shifting. So that's a 120. Everybody good so far? Angle of rotation about O that maps P to G. Here's P. You're going to G. You can count the spaces or count the dashed lines if you want, or what would this rotation be right here? There's 180 of it. And then how many more do you go? You go 2 more dashed lines, don't you? And aren't they 30 each? So 180 plus 60, 240. A lot of 240s showing up in this study guide, but they're not. It's not going to be that consistent on your quiz. So make sure you understand how to get from P to G around O and how to determine the correct angle of rotation. Good? Alright, number 5. Find the degree of rotation about the spinner center. Here's your spinner center. That maps I to G. Here's I. You're going to G. Well, you need to determine how many degrees each piece of pi is. So you count them. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces, right? So if you take 360 degrees, which is the complete circle, you divide it by 10, you get 36 degrees per segment or section, right? So how many sections do you rotate to get from I over to G? 2, good. So 36 times 2 equals 72 degrees. See it? Number 6, it's asking for how many lines of symmetry does the figure have. So there's another reason that you're going to have to know what line of symmetry means. If you put the center in that shape, that octagon, yes, octagon's got 8 sides. A line of symmetry, if you cut this thing in half vertically, doesn't that create a line of symmetry? Right side's the same as the left side. It's a mirror image. Then you can do the same thing horizontally. Top would mirror the bottom. And then one diagonal here, 2 diagonals. Oh, that's a bad one. You see how all of these lines create mirror images? Now, look at this. You can go through here too, can't you? And if you can do that through these 2 vertices, so you had 4 red ones, right? And then you had 5 was the black one. Then wouldn't this be another one? That would be 6. Then you would have 7. Then you would have 8, wouldn't you? Okay. So lines of symmetry does the figure have? This one's got 8. Do you notice anything about the lines of symmetry and the number of sides? Okay, they're the same, aren't they? But be careful if it was like a square, right? Because if you had a square, how many sides does the square have? It's got 4, but lines of symmetry, you got 1, you got 2, you got 3, You got 4. Oh, it'd work anyway, wouldn't it? So that's probably a good thing to pay attention of. If it's a regular polygon. Now, if it's irregular and the sides are different lengths, it's a different story. But that might be a coincidence. Or it might be a rule. I'll let you decide. Alright, number 7. This kind of breaks the rule of what we did yesterday. And I don't know why or what. But the dashed lined figure is the dilation of the solid. So the solid is the pre-image, the dashed is the image. Is the dilation an enlargement or a reduction? And what's the scale factor? So are we going bigger or smaller here? We're going bigger, so it's an enlargement. Now, if it's an enlargement, is your number going to be a fraction or a whole number? It's going to be a whole number because it's got to get bigger, right? You got to multiply by something. So look at these side lengths. Let's get a side length of the pre-image. This side right here is 2 units long. Because remember, the grid lines represent 2 units. And then the side length of the image is 2, 4, 6 units long. So we're going from a 2 to a 6. So what's our scale factor? It's 3. And in number 7, do we have a enlargement or a reduction? We got a reduction. So is our scale factor going to be a whole number or a fraction? It's going to be a fraction. So we're going to compare side lengths again. So if we take this top side of the pre-image, and it is 2, 4, 6, 8, 10, 12 units long. The top side of the image is 2, 4, 6 units long. So when you reduce something from 12 down to 6, what do you reduce it by a scale factor of? 1/2. Good. Number 9. Blueprint for a house has a scale of 1 to 35. It's a blueprint, right? It's a drawing, so it's going to be a lot smaller than the house. So your blueprint to house is 1 to 35. And a wall on the blueprint is 3 inches. So it's on the blueprint, so it stays in the numerator. What is the length of the actual wall? So we're looking for the length of the wall. So you crisscross multiply, and your L times 1 is L, and your 35 times 3 is 105 inches. And if you take 105 inches and you divide it by 12, you get 8.75 feet. So there's your length of the wall. Number 10, a microscope shows you an image that is 80 times the object's actual size. So when you look at it through the microscope, it's 80 times bigger. Agreed? So the scale factor of the enlargement is 80, so it's 80 to 1. An insect has a body length of 7 millimeters. So where's the 7 going to go? Or here's the question, what is the body length under the microscope? Isn't the microscope 80 times bigger than the actual? Alright, so really if you wanted to clear this up, because I know this is confusing for a lot of people. This is the microscope, right? This is the actual. Your microscope to actual is 80 to 1. The insect has a body length of 7. So the 7 is the actual. What is the body length of the insect under the microscope? So you're looking for your microscope length. So your 1 times m is m, and your 80 times 7 is 560, and that's in millimeters. And number 11. Zoom feature on a camera allows you to dilate what appears on the display. When you change from 100% to 500%, the new image on your screen is an enlargement of the previous image with a scale factor of 5. So let's call it the new image, and I'm going to make this an O. So we're going to say you've got the original image, and then you zoom in, and you get the new image. And it's 5 times bigger, right? So that means the new one is 5 times bigger than the original. So that your scale factor is 5 to 1. So now let's see. If the new image is 47.5, the new is 47.5. So where does our 47.5 go? Stays in the numerator. What is the width of the previous image? I'm going to call it the original. No, I'm not. We're going to call it a previous. So I'm going to change this to a P for previous. Previous to new. Because the 5 times the O would end up looking like a 50, wouldn't it? So we got 5P when we crisscross multiply equals 47.5. And if you divide both sides by 5, these will cancel. And your P is equal to attaboy, 9.5. And what's that in millimeters? Got it? Okay, so not really that many quiz questions, but you're going to have those vocabulary matchings. There's going to be 2 more questions on the quiz that I'm not going to put on the study guide, but you should know how to do them. And then you're going to have to answer your EQ. In order to answer your EQ in the amount of words that I am willing to read, I'm going to have to ask you to answer one portion of each EQ. Like, remember when we talked yesterday about, was it rotating an image about a point? Or on Monday, rotating an image about a point? And we said something like, all vertices remain the same distance from the center of rotation. A line drawn from the vertex to the center of rotation back to the image creates the angle of rotation. I'm probably going to be asking you to tell me about one of the topics inside each EQ. Got it? So be able to answer the essential questions, like I'm sure you already have because it was part of your assignment, but then also practice answering some questions about just one part of each EQ. Got it? Okay. It was an honor and a pleasure to do this study guide with you today. Please spend the rest of the period working on answering your essential questions and learning the definition of those terms that I put up at the beginning of the study guide.